So here we have another example of multiplying two matrices. So it is always said that before you start multiplying two matrices, you must verify if multiplication is possible. And how you do that? You count the number of elements in the row of the first matrix. Because when you see multiplying matrices, there'll always be a first multiplied to a second. That's how it will be laid out. First times the second in a horizontal fashion. So you count the number of elements in the row of the first. Then you count the number of elements in the column of the second. Okay. And if those two counts are equal, then multiplication is possible. If not, then multiplication is not possible. So let us count the number of elements in the row of the first. First, second, third. 1, 2, 3. That's 3 elements in the row of the first. First, second, third. 1, 2, 3. 3 elements in the column of the second. Okay, so there are 3 elements in the row of the first. Okay, there are 3 elements in the column of the second. Okay. So as you can see, those two counts are equal. So since these two counts are equal, then multiplication is possible. And this is very important because multiplication of matrices involves a product sum. You multiply and add, because you have to multiply each corresponding elements in the row of the first to its corresponding counterpart in the column of the second. So in the row of the first, you have first, second, third. So you must have a first, second, third in the column of the second for multiplication is possible. Okay, so you have a first, second, third, right? So first times first, second times second, third times third, and then you add. Okay, so that is what is actually going to take place. Okay, so when we come here, we write the column matrix. Okay, we're going to go back into equations. Matrix. We want a row matrix. So we're looking on the matrices and get a row. A row with, all right, always good to put your bracket first. And in the bracket, all right, inside of the bracket, yes, we put a row matrix times, get another bracket, and in the bracket, we put a column matrix. Okay, so therefore now we have 6, 3, and 4. Okay, and then we have 1, 2, and 0. Okay, equal. So put our bracket, because bear in mind is matrices, so you have to have brackets. You must put a bracket. So it's the first times first, that is 6 times 1. Okay, the first in the row, first in the column, plus. So that's why there's always a plus when you multiply in matrices. Not every time, but most of the time. Plus 3 times 2, second times second, 3 times 2, plus third times third, the 4 times 0. Okay, and then you get your answer. Your answer have to be in a bracket too, because we're talking about a matrix. So let us just take this product sum. Okay, product sum. And then we get 12. Okay. And if you notice now, the matrices, we have a 1 by 3, 1 row, 3 columns. And then we have a 3 by 1, 3 rows, 1 column. And we get a 1 by 1. And the reason for that, the product will have the same number of rows of the first, and it will have the same number of columns of the second. So we can just take a note of that now. Also take note that the product will always have the same number of rows of the first, okay, and number of columns of the second. Okay, so if the first have 1 row, the product will have 1 row. If the first have 1 column, the product will have 1 column. So it's like always row column, always row column. First, to identify the size of a matrix, row by column. You could remember, row by column, a 2 by 3, a 2 by 2, a 1 by 4, 1 row, 4 columns, 1, 2, 3, 4 columns, row by column. When you want to find the size of a matrix, when you want to identify the position of an element, those 2 numbers below in the subscript, the first number is the row, the second number is the column, row, column, okay, in that order. So this matrix, for example, that -6 there, the position, first we get the number, in the row it is 1, 2, 3, 4, it is in the 4th row. Column 1, 2, so it is in the 2nd column, so it occupies the position 4, 2. 4th row, 2nd column, row by column. When it comes to multiplying matrices now, we have to count the number of elements in the row of the first. Okay, again, the whole concept of row of the first again, and then column of the second. So we count the number of elements in the row of the first, number of elements in the column of the second, and then multiplication is possible. And the product now, the answer, will always have the number of rows of the first and the number of columns of the second. Okay, so just bear that in mind as we're moving forward.